Good afternoon, everyone, and welcome to this lecture. We were dealing with relative motion, and in today's class, we will start relative motion in 2D. Relative motion in 1D is almost over. I think we were discussing one problem in the previous class. Does anyone remember that problem? That problem was about two projectiles. One projectile thrown downwards with a speed of 20 meters per second, and the other projectile thrown upwards, another ball thrown upwards at the same time. Do we remember this question, everyone? I think you were able to solve this, yes or no? Well done. So 5 seconds was the, I think, answer. And how are we supposed to solve it? I will just quickly draw a diagram and try to make sense. So the diagram was like this. This is ground. This is, let us say, my tower. Here we have ball number A, and here we have ball number B. Ball number A is thrown downwards 20 meters per second. Ball number A is thrown upwards 30 meters per second. And the height of this tower was 150 meters. We will see more questions of this type of projectile. This was projectile motion in 1D. So now, as I told you, how you can solve this question? You can solve this question by either becoming A or becoming B. Let us now become B. If I become B, so remember, if I become B, B is not going anywhere. B is at its own position. Everything moves around B. So what is the first thing that I calculate? I calculate velocity of A with respect to B, minus 10 minus plus minus 10. Why I'm writing minus 10? It is minus 20. Minus 20 because it is downwards, minus plus 30. So it will become minus 50. Do we all understand this? Yes or no? I'm not writing the units. I'm doing it quickly. Now, remember, what is the acceleration of A with respect to B? Remember, both are projectiles. Both have the same acceleration, G downwards. And therefore, the acceleration becomes 0. As soon as the acceleration becomes 0, this becomes a very simple problem, because now we know what is the displacement of A with respect to B. Remember, B is not going anywhere. B is at its position. How is A coming? A should come down. Yes or no? A should come down, and the displacement of A would be minus 50 meters. Now you can apply the formula. Displacement of A with respect to B will be equal to initial velocity of A with respect to B. Here I written V. I should have written initial velocity. If I write initial velocity or if I write final velocity, doesn't matter, because acceleration is same. Initial velocity of A with respect to B into T plus half acceleration of A with respect to B into T square. All of us know that this term turns out to be 0. So you basically have to divide the displacement, which is minus 50, divided by minus 5, and you will end up with the answer. And what is the answer that you will end up? You will end up with the answer of T time is 3 seconds. Now, but that is not the only question they can ask. They can also ask, where are these particles going to meet? So what you do? Then you make the equation of body A, or you make the equation of body B in with respect to ground, and then you can find out where they are going to meet. So I'm giving you this small question to start off today's class. Where are they going to meet? We have already known when are they going to meet. The next question is, where are they going to meet? From ground, you have to tell me where they are going to meet. You have 2 minutes to solve this. Tell me the answer quickly so that we can move ahead in life. Where are they going to meet? Yes, beta. Where are they going to meet?
90 meters.
90 meters. 90 meters from the bottom of the building. Is that so?
Yes, sir.
I am afraid that is not the correct answer. Remember, do not jump onto answers very quickly. Do not jump onto the answers very quickly. Remember, the body is a projectile. The body is a projectile. Have patience. Take a long breath and then think. You know the initial velocity is 30 meter per second. If you look from body B, I'll give you 1 more minute to think about it. Anyone with the answer? Yes. I don't know what is wrong with the voice, but I think someone has understood this. So what I do, either I can make the equation of A or I can make the equation of B. If I make the equation of A, I will get displacement from top. If I make the equation of B, I will get displacement from the bottom, from the foot. That is what I want. So I will make the equation of B. Displacement of B with respect to ground will be equal to initial velocity of B with respect to ground into T plus half acceleration of B with respect to ground into T square. In this equation, I have to put the value. So the displacement of ball B with respect to ground, initial velocity of ball B with respect to ground is plus 30. I hope everyone can see this. Plus 30 multiplied by the time taken by the two balls to meet. Time taken by the two balls to meet is 3 seconds. Why I have not written 3? I should write 3. So multiplied by 3 plus half. What is the acceleration of B with respect to ground? It is minus 10. Don't forget this, into 3 square. From here, you will get the displacement, how much B has moved with respect to ground, and that is where they are going to meet. Do we understand this? It is not simply 30 multiplied by 30. This is not a case of uniform velocity with respect to ground. With respect to ground, it is not uniform velocity. With respect to B, A with respect to B or B with respect to A, that is uniform velocity. Remember, relative motion we are doing. Don't forget that sometimes, even in relative motion, we have to go back to ground and see how they move. Do we understand this? Yes or no? Okay. Now, since we are done with this, I've seen some questions of train also. So let me see if I can get that question. Just give me a minute. I've seen a question of train. I can obviously make that question, but if I get that question, it would be better because then I will not have to make that question on my own. So let me see if I can get that question. Let me see if I can get that question. Where is that? Where is that? Just give me a minute. I've seen that question somewhere. If I can get that, I will straight away give it to you. Okay, I've got that question. Let's see, this question has come many times in different exams. And now it is coming for you. Let's see if you can do justice to this question. Here is the question. Two trains, each of 50-meter long, are traveling in opposite direction with velocities 10 meter per second and 15 meter per second. How much time they will take to cross each other? Question number 2 for today's class. The options are there: 2 seconds, 4 seconds, 2 root 3, 4 root 3. Yes, my dear friend, I'll give you 2 minutes. Tell me when you have got the answer.
Sir, option A.
Option A, 2 seconds. No, that I am afraid is not correct. 2 seconds is not correct.
Sir, option B.
If it is not 2, then it is 4 because the other two options are obviously not looking correct. Yes, the answer is 4, but the more important thing is how did you get that answer? So to get that answer, what do we do? Let me make this train number 1. Let us say this is the engine of the train, and let us say that this is the last bogie of the train. Now, normally the engine of the train, if I draw it, I will draw it as a dot because that is the front. When you see an engine, you see the light. And when you see the last bogie of the train, you see a cross, dot and cross. This is the first train, let us say, and the length of this train is 50 meters. Now, we are assuming here, since nothing is given, that the other train would be somewhere like this. The other train would be like this. The engine would be here. The tail light would be here. And this is also 50 meters. Now, the best way to solve this question would be in terms of relative motion. We become one of the trains and we see the other train. So what I'm going to do is I'm going to become train number 1. I'm going to become train number 2. Now, once I become train number 2, train number 2 does not go anywhere. So this just remains here. Now, when train number 2 does not go anywhere, when is train number 2 does not go anywhere? When will train number 1 cross train number 2? Remember, train number 2 does not go anywhere now because we have already become train number 2. So we are not going anywhere. When does train number 1 cross train number 2? Tell me. When does train number 1 cross train number 2? Train number 1 will cross train number 2 when the last bogie leaves the last bogie of the train. Yes or no? So the two black ones are the initial position of both the trains. The red one is the final position of the other train because the second train is not moving because I have become the second train. So first of all, I will find out the velocity of first train with respect to the other train. I take this direction as positive. I always take this direction as positive. So this is the train are moving. This train is moving with a velocity of plus 10 minus this train is moving on the other side with a velocity of 15. So it is plus 10 minus of minus 15. So velocity of 1 with respect to 2 becomes 25 meter per second. Yes or no? Now we look at how much distance, what is that, say there is no acceleration, you just have to find out the displacement of the first train. How can you find out the displacement of the first train? You look at the engine of the first train and you look at the engine of the train when it has crossed the train and you find out how much is the displacement of this engine. Either you can find out the displacement of this engine or you can find out the displacement of the last bogie. Doesn't matter, both are same. How much is the displacement? How much is the displacement? How much is the displacement?
100.
It is plus 100 meters. There is no acceleration, so you can easily find out how much time the first train will take to cross the second train. The displacement, it has to, the displacement is 100 meters. The velocity or the initial velocity is 25. There is no acceleration. So you can simply divide the displacement by the initial velocity and you will get your time. Your time will come as 4 seconds. Do we understand this, how this is done? So to draw the diagram, see how it is done and simply do it. This question is easily solved by the concept of relative motion. If you try to solve it from ground, you can also solve it, but it might take more time and you might make some sort of a mistake. So it is always better to solve it in this way. Okay, do you understand this? Have you noted it down? Do you want me to solve one more question of this type? Okay. So it is not exactly similar, but it is similar in some aspects. Let's see. Instead of now 2 trains, I have a train and a bird. A 210-meter long train is moving north with a velocity of 25 meters per second. A small bird is flying south a little above the train with a speed of 5 meters per second. The time taken by the bird to cross the train is. I give you 2 minutes to solve this.
Six.
A, B, C, D. What is the answer?
A.
6 seconds. I'm afraid that is not the correct answer. How did you get 6 seconds? Not getting
Yes.
Yes, bacha?
7 seconds.
7 seconds is correct. Everyone got this? Yes or no? Okay. How are you supposed to do this? Again, I do the same thing. I draw my train. Let us say this is my train. This is the engine. And this is the last bogie. And I'm taking this direction as north. Okay. Now, this is my bird B. This is my bird B. Bird does not have any length, so bird is only a point. Now I can become the bird, I can become the train. I have decided to become the bird. So I am not going anywhere. A train is going to pass through me. So first of all, I find out the velocity of train with respect to the bird. Remember, the train is moving northwards with a velocity of 25 meters per second, whereas this gentleman bird is moving with a velocity of 5 meters per second towards south. I can take one direction as positive, I can take the other direction obviously as negative. So what will be the velocity of train with respect to the bird? It will be plus 30, yes or no? Now this is the initial position of the train. When will the train cross the bird? Remember, bird is only a point. When the train becomes like this becomes the engine and this becomes the tail light of the bird, tail light of the train. Now you look at how much distance the train has moved. You can look at the distance between the engine and the engine, or the last bogie and the last bogie. Obviously, the train has moved a distance of, or the displacement of 210 meters. Yes or no? You know the velocity, initial velocity, there is no acceleration. You can straight away calculate the value of time. Time is 210 divided by 30, and you will end up with 7 seconds. Do we understand this? Yes or no? Great. So this is how we solve questions of this type, I'll give you 2 minutes to note this down.
Done, sir.
You got this, everyone? We have noted this down. Okay.
Yes, sir.
This was more or less the question on relative velocity in one dimension. Then we should move on to relative velocity or relative motion in two dimension. We have already seen how will you find the relative motion in 1D or 2D. Just to take you back, to find the position vector, you subtract the position vector of B from A. To find the velocity, you subtract the velocity of B from A. To find out the acceleration, these are the equations we have already written, and these equations are valid whether the motion takes place in 1D, 2D or 3D, yes or no. So there is no point of going through this again, and we can straight away begin with a question that you might have to find out the relative velocity of someone with respect to the other one in two dimension. Are we ready for this? Yes. So here is the first question. It's a straightforward question, and I hope that you will be able to give me the answer for this one. And this is the question coming on your screen now. Object A and object B have both same speed, 10 meter per second. A is moving towards east, B is moving towards north, starting from the same point as shown. What is the velocity of A relative or with respect to B? You have 2 minutes to solve this. Yes, bacha. Anyone with an answer? No one? Okay, I'll give you time.
0, sir.
I have an answer, and the answer is definitely what? 0. Great. What type of, how did you get 0, beta? What, sir? Tell me, how did you get 0, beta? Who got 0?
Velocity A minus B.
Velocity of A minus V. Well done. So this is 10. This is 10. 10 minus 10 is 0. Yes or no? Everyone got this answer? Boys? Well done. Democracy. We have got a democratic answer. 10 minus 10 is 0. But remember, in physics, democracy does not win. In physics, science and logic wins. And science and logic says that this is absolutely wrong. So now, try again. Yes? Do we have an undemocratic answer? Someone who got a different answer than 0? Yes, beta?
20.
10. Not able to hear your voice, beta? Still can't hear your voice. What is wrong when still can't hear your voice?
20.
20. 10 plus 10. If it's not 10 minus 10, it has to be 10 plus 10. Undemocratic answer. This answer also does not win because this is wrong.
10 root 2.
10 root 2, the third undemocratic answer, and that is correct. 10 root 2 is the answer. How many of you got 10 root 2? See, there were people who got 10 root 2 but were shy to say 10 root 2 because they thought that 0 is the answer. Remember, velocity is what type of quantity? It's a vector quantity. The most important thing about velocity is the direction. If you forget the direction, velocity will kill you. And it has killed a lot of people. Just now, 10 minus 10 is 0. 10 minus 10 is 0, but that is when 10 and 10 are numbers. That is not when 10 and 10 are velocities because they have directions. So how do you find out? There are two ways of doing it, and I'll tell you both the ways, and then I will leave it to you how you want to do it. First of all, I have to make a axis system. So this is my y-axis. Everyone knows this, and this is my x-axis. This is motion in 2 dimensions. So now I can write the velocity of A. What is the velocity of A? Remember, we have got a unit vector I and a unit vector J. Do we remember this I and J? I and J, anyone? Okay. What is the velocity of body A? It is 10I. Do we understand this? 10I. This is with respect to ground. I have not written G. What is the velocity of B with respect to ground? That is 10J. Then I had to find out velocity of A with respect to B. That is velocity of A, 10I minus 10J. Then if you ask, I can also find the magnitude of this velocity. The magnitude of this velocity is what normally it is asked. It will be under root of x square, 10 square plus y square. So that gives me 10 root 2. Do we understand this? You also must understand the direction, my dear friends. So to find out the direction, what do? I find the angle tan theta. It is y divided by x. Don't forget. 10 divided by 10, and it is equal to 1. You must all understand how I have found out this velocity of A with respect to B. I have subtracted the velocity of B from the velocity of A. Do we understand this? And bacha, this is how I have done this. So I'll just show you the diagram instead of drawing it myself. This is what I have done. Do you see this? This is the velocity of A. This is the velocity of negative the velocity of B. And this is the resultant velocity. Do we understand this? Yes or no? One more way of understanding this is in terms of the direction part. So I gave you one more diagram which is given in terms of direction so that you understand it completely. A is going towards east. B was going towards north, but I have to subtract the velocity of B. Therefore, I have taken negative of B. Negative of B is going towards south. And the resultant velocity VA minus VB is this velocity which makes an angle 45 degrees. Do we understand this? Remember, velocity is a vector. So this is one way of doing it. One way of doing it is the original way of doing it. And the original way of doing it requires you to convert them into vectors. The original way requires you to convert them into vectors, convert A into vector, convert B into vector, and then you subtract vector B from vector A. We understand this? The other way to do this is by using the formula of addition of two vectors. Have you noted this down, everyone? Have you understood what has been done here? Boys? I don't get raised hands from you. Everyone understands this, what we have done? The other way of doing it might be more simpler for you to understand. So you can write this way number 2. You may not get question that you have to do it this way. So you can use the shortcut way. So remember the shortcut way. There were two vectors, vector A and vector B. And if I had to find out the magnitude of vector A plus vector B, we call it resultant vector A plus vector B. And if I had to find out the magnitude, can anyone tell me what was the formula of magnitude of A plus B? Vector A and vector B are two vectors inclined at an angle of theta. Tell me fatafat.
Under root a square plus b square.
A
Plus
square,
2ab.
A square plus B square plus
2ab cos theta.
2AB cos theta. This was A vector plus B vector. But if I have to do A vector minus B vector, then what will I do? So this is my A vector. This is my B vector. I hope everyone needs to see this. This angle is theta. But if I have to do A vector minus B vector, what I need to do, bacha, is I need to put the negative of B over here, opposite to B. Do we understand this? Now the angle between A vector and B vector becomes 180 minus theta. Do we understand this? Now I can write this formula for the subtraction of two vectors. A vector minus B vector ka magnitude will be equal to, can anyone tell me what will be the answer for this?
A square plus b square minus 2ab sin theta.
How did sin theta come?
Cos theta.
Cos theta, sir.
Cos theta. A square plus B square. Actually, it is plus 2AB cos of 180 minus theta. But math students, we know this. Cos of 180 minus theta is minus cos theta. So the answer becomes A square plus B square minus 2AB cos theta. Do we understand how I got this? Now I can use this formula. I can use this formula to find out the relative velocity of A with respect to B. Have you noted this down formula? Have you noted this formula down? Everyone? Then I can use this formula to find out the relative velocity of A with respect to B. So that will be my method number 2. If you remember the diagram, A was here 10 meter per second. This was A. B was here also 10 meter per second. Both the lines must be equal, but I have not drawn them equal. The angle between them was 90 degrees. I can find out A vector minus B vector ka magnitude. A vector minus B vector ka magnitude will be equal to under root of, in this case, 10 square plus 10 square plus, no, it should not be plus because I'm subtracting, so it should be minus. So I write minus 2 into 10 into 10 into what is the angle between them? Cos of 90, but cos of 90 is 0. So we end up with the same answer that we got, 10 root 2. So this is the velocity of A with respect to B, the magnitude of that velocity. Do we understand this? You can use this, you can use the original one depending on what you feel good about. I will leave it here for you. You understand this, everyone? Okay. Let us now move on to the next question. Are we ready for the next question? In the next question, if you can do this, nothing like it. If you can't, don't worry. Not many people will be able to do it. Anyways, let's see if you can manage this one. This question has a diagram also, so I need to put the diagram also. And the question comes here. Read the question carefully. This is question number 3. Two particles A and B are projected in air. Remember, they are projected in air, so they are basically projectiles. A is thrown with a speed of 30 meters per second. You can see A. B is thrown with a speed of 40 meters per second as shown in the figure. What is the separation between them after 1 second? After 1 second, what is the separation? You have 2 minutes to find it out. Anyone with any answer?
50.
Yes?
50.
50. 50 is right. How did you get it? 50 is right. Yes? Only one student got it seems. Okay, I'll give 1 more minute for everyone else to do it. Remember, it's a difficult question. It's not an easy one. Try to understand that both of them are projectiles. This gentleman is going to go like this, dang 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 dang. This gentleman is going to go like this, dang 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 dang. They are both projectiles. I hope you understand this. You understand this now? Both are projectiles. Sometimes you might end up with the right answer by not doing the question correctly also. But you must understand both of these are projectiles. And you have to find the distance between the two projectiles. So both of them are projectiles. I hope you can see them now. This is projectile number A. This is projectile number B. After 1 second, this could be somewhere here. After 1 second, this could be somewhere here. We actually have to find the distance between these two. I hope you understand it's not a easy problem, right? Anyone who got the answer, can anyone explain how 1 meter you have got? Which is the right answer? 50 meters, sorry, not 1 meter. Okay, I'll give you 1 minute. Do you want me to solve it? Do you want me to solve it? Now, before solving this, remember some important points and keep them in mind. Number 1, A and B both are projectiles. Yes or no? So if I find the acceleration of A with respect to B, or if I find the acceleration of B with respect to A, both the acceleration are going to come as what? What is the acceleration of A with respect to B, or the acceleration of B with respect to A? No one knows it?
0.
0. Now that is a very important aspect. The accelerations are 0. Now, what is given here is the initial velocity of A with respect to ground and initial velocity of B with respect to ground. We can obviously solve this question from the ground frame, but from the ground frame, as you can see, both are projectiles, both are moving in parabolic path. It becomes a difficult question. But the question becomes very simple if you become one of the projectiles. Say, for example, and I always like A, I become the body A. Oops, green is not good for body A. We are using pink for body A. I become body A. I become body A. So I also become a projectile. Now, whatever I see, my dear friends, is with respect to body A. So first of all, I find out initial velocity of B with respect to A. Now, there are different number of ways in which you can find the initial velocity of A with respect to A. But you see one thing, and that is how you observe. The velocity of A in magnitude is 30 and this is 40. And the angle between the two velocities, how much? 90, yes or no? The question is designed in such a way. Wherever you see 30, 40 as two numbers, the angle or the velocity or force or whatever will be always 90, because 30 squared plus 40 squared is a Pythagorean triplet. It will be 50 squared. So if I find the initial velocity of B with respect to A only magnitude, it will be 30 square plus 40 square minus 2ab cos 90. 2ab cos 90 is 0. So you will get 50 meter per second. Yes or no? Everyone understands this? Okay. Now, remember, there is no acceleration of A with respect to B. There is no acceleration of A with respect to B. There is no acceleration of A with respect to B. Now, how will the motion of B look to A? If I become A, I am also a projectile, and B is also a projectile. The velocity of B with respect to A is 50 meters per second, and there is no acceleration. The acceleration of B with respect to A is 0. My question is, how does the motion of B look to A? How does it look? I am B, I'm looking at A. How will A move? How will B move? The motion of one projectile with respect to the other projectile when both of them are in air is always a straight line. Motion of one projectile with respect to the other projectile. When I say projectile, they are moving under gravity. Do we understand this? When both are in air, is always in a straight line. To the other projectile, the first projectile will always look like moving in a straight line. So now, when I become A is moving in a straight line with an initial velocity of 50 meter per second. There is no acceleration. So after 1 second, how far he is from me? It is very simple. How far he is from me? How far is he from me? He will be at a distance of, or the displacement of, because he's moving in a straight line, the displacement of B with respect to A will be simply 50 initial velocity multiplied by 1 plus whatever is 0. So he will be at the shortest distance of 50 meters from me. Are we getting this point? Yes or no? Great. I'll give you 2 minutes to note this down. And I'll give you more points on this. First, you note this down.
1, sir.
Everyone got this? Okay. If I make a question now, let us say, for example, what will be the conditions of two projectiles to meet? And on this condition, they have asked a lot many questions, not in JEE Main, but in JEE Advanced. They've asked a lot of questions on this. And I will ask you, let us suppose that we have two projectiles and it is the simplest possible case. One is thrown from A, other is thrown from B. From A, I throw it with a velocity u1 at an angle theta1. From B, I throw it with a velocity u2 at an angle theta2. Obviously, their range, what is the first condition I have to put? If the distance between them is d, the first condition that they must fulfill is r1 plus r2 should be greater than d. Do we understand the meaning of this? The sum of their range must be more than the distance. And if they are very far apart, whatever happens, they are not going to meet. Yes or no? We understand this? So they must be. Okay. Now, when will they meet? How will they meet? What is the condition for them to meet? There is only one condition for any two particles to meet. It's always there. Provided that there is no acceleration. There is no relative acceleration. If there is relative acceleration, then the condition becomes different. But here you can also see that the acceleration of A with respect to B is equal to acceleration of B with respect to A is equal to 0. Do we understand this? Yes or no? What will be the condition of these two projectiles to meet? To understand that condition, what you got to do, and you will just remember it as a point, you will become any one of these particles, right? You can become B. Now, if you become B, then B is not going anywhere. Yes or no? B is not going anywhere. A should go wherever A has to go. Now, if B is not going anywhere, what should happen is relative velocity of A with respect to B should be along the line AB. Yes or no? That is the most important condition for two particles to meet. Number one, relative velocity of A with respect to B must be along the line joining the two particles AB. Understood or not? Because when you become B, bacha, when you become B, B does not go anywhere. Now A has to come and meet you. How will A come and meet you? If the velocity of A is towards you, then only he will come and meet you. Yes or no? Now, in this case, in this particular case, what will happen is that we will resolve these velocities along two components. This will be u1 cos theta, this will be u1 sin theta 1, and this will be u1 cos theta 1. This will be u2 sin theta 2, and this one will be u2 cos of theta 2. Now, the relative velocity of A with respect to B should be along the line. That means these two components should cancel each other out. Otherwise, if these two components do not cancel each other out, the velocity will not be along AB. So the condition here in this case becomes u1 sin theta 1 equals u2 sin theta 2. Do we understand this? Yes or no? How much time they will take to meet? How much time they will take to meet? So now remember, B is not going anywhere. B is at this position only. This is just like motion in 1D. B is here only. Now A has to come and meet you. How much distance A has to move? How much distance A has to move? A has to come and meet you. B is not going anywhere. The distance is D. Yes or no? Because there is no acceleration. The distance is D, and what will be the velocity of A with respect to B? It will be u1 cos theta 1 minus u2 cos theta 2. They will get added up. So the answer will be u1 cos theta 1 plus u2 cos theta 2. These type of questions are only coming in your JEE Advanced. They might not come in JEE Main. Do we understand this? This is the condition for two projectiles on the same ground, same horizontal ground to meet. Everyone has noted this down? Similarly, this was the case of two projectiles to meet. We can make a similar case for two body moving with uniform velocities to meet, and the case would be simpler. Case would be similar if two uniformly moving bodies, here we have taken the examples of two projectiles, they are not uniformly moving, but from one projectile the other projectile is uniformly moving. If you have two uniformly moving bodies, say for example the same diagram but with a difference, these are two bodies moving with uniformly with velocity v1 and v2. These are not projectiles, these are two bodies which are moving with the same with velocity v1 and v2. These are two bodies, these are not projectiles, these are two bodies moving with velocity v1 and v2. What will be the condition for them to meet? The relative velocity should be along the line. Do we understand this? Yes or no? Again, if you apply that condition here, you will get this equation. v1 sine theta 1 will be equal to v2 sine theta 2. Do we understand this?
Sir.
After how much time they will meet? It is always equal to d by u1, sorry, d by v1 cos theta 1 plus v2 cos theta 2. This was the case with uniformly moving bodies. The same case is applied to projectiles, because from one projectile the other projectile is moving in a straight line. Do we understand this, everyone? I hope you will note this down. We will move ahead and solve one or two problems based on this. Simple problems, no complications. In the next class, I'll see you in the next class. Take care. If you have any doubts, you can always come up. Bye bye.
Sir, wait a minute.